Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan Abu Bakar and my numeric is AA200191. Me and my friend are from group section 7 Dynamics that assigns the 7.3 question. So I will present the introduction. Force, mass and acceleration are everyday terms that are frequently misused. Force is a physical influence that causes an object to accelerate in the direction from which it was applied. The amount of matter in a thing is measured in kilograms, while the rate of change in velocity of an object in the same straight line as the unbalanced force is defined as acceleration. When the forces are balanced, there is no net force and thus no movement. So, Newton's second law connects these three words and deals with the effect of an imbalanced force on the motion of an item. It asserts that an object's rate of change of velocity is directly proportional to the force applied and occurs in the direction of the force. Thus, the equation for Newton's law is F equal to ma, where F is force, m is mass, and a is acceleration. As a result, an object of constant mass accelerates in proportion to the applied force. Gravity is the changing attraction force between any two things. Every matter has a gravitational pull towards other stuff. The quantity of gravitational attraction between two objects is determined by their mass and their distance between their centers. In its correct context, the term weight refers to the downward vertical force imposed on an object as a result of the Earth's gravity. Thus, an object with a greater mass is subject to a stronger gravitational force.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad Akmal bin Abdul Halim, matrix number AA200308. Alright, so today I'll be explaining regarding the background case study of our project. Alright, so our case study is the real-life application of rocket sled testers, or rather known as rocket sled. So what is rocket sled? Rocket sled is a propelled vehicle that runs usually on a single rail and is used in aeronautical experimentation. So rocket sleds was extremely used in the Cold War. This is to accelerate the equipment that is considered too experimental or hazardous for testing directly in the piloted aircraft. Thus, this equipment is need to be tested under high acceleration or under high speed conditions. Thus, it was installed with the appropriate instrumentation, data recording, and telemetry equipment on the sled. So, this sled was then accelerated according to the experiment design requirements for data collection along a length of isolated, precisely level and test track. Alright, now moving on. From our case study, there are several objectives that we want to achieve. So this project aims to develop our understanding regarding force, mass, and acceleration. Thus, in general, thus Newton's second law links these three terms and concerns the effect that an unbalanced force has on the motion of an object. So, what is the main objective of our case study? The main objective of this project is to apply the force, mass, and acceleration, which in this case Newton's second law of motion, on a real-life application, which is the rocket sled tester, or other known as rocket sled. Alright, Now, besides the main objective, which is to understand the force, mass, acceleration, or Newton's second law in general, there are other specific objectives that we want to achieve as well. So, what are the other specific objectives? So, the other specific objectives are as follows. First, to identify the type of forces acted on an object and to use the information to construct a free body diagram. Secondly, we want to state the Newton's second law of motion, thus to express in equation form and to use it to solve for acceleration, mass, or net force. If the knowledge of two of these three variables are known. So lastly, we want to use the Newton's second law equation as a guide to thinking about the relationship between force, mass, and acceleration. Alright, so now I'll be explaining regarding the basic theory of our case study. So, kinetic of particle is a study that focuses on the relationship between force and motion. So, when we are going into depth regarding the kinetics of particle, it does not concern whether force causes motion or the motion itself generates the force. Thus, regarding this project, the kinetic of particle mainly focuses on the particle itself. That's the body whose physically dimensions are so small compared with the radius of curvature of its bulk. Now, there are three ways of approaching kinetic problems. The way are Newton's second law of motion, work and energy and impulse and momentum. However, for our case study or this project, we are simply focusing on Newton's second law. Now, in definition, Newton's second law states that acceleration of an object is directly proportional to the net force, and it's also inversely proportional to its mass. This simply means that the acceleration of an object depends on two things, which are force and mass. The equation of the Newton's second law is F equals to ma, whereby F is the resultant force acting on a particle, m is the resistance or rather known as rate of change of velocity of the particle, and a is the resulting acceleration measured in. Thus, the equation F equals ma is referred to the equation of motion, and it is one of the most important formulas in mechanics.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Fadis bin Andi Saimi. So, I will present to you about the calculation. So, this is the question. Okay, what rocket thrust accelerates this lead? Okay, rocket slide tester, missile equipment, and psychological impact were used on human subjects at high speed prior to space trip carry astronauts. It was a platform mounted and powered by various rockets on one or two rails. Okay, calculate the magnitude of the force used by 4 rockets propulsion system called its thrust. Okay, the slide's initial acceleration is 55 meter per second, so the mass of the system is 3,000 kg, and the force of friction opposing the motion is known to be 700 Newton. So we got the sub-info from the question, where the mass m equal to 3,000 kg, acceleration a equal to 55 meter per second, so friction F equal to 700 Newton, and force T equal to rocket propulsion. So for the rocket propulsion, we got for rocket propulsion, so we got the 4T. Okay, we use the formula F equal to ma, where the F equal to 4T minus F, so we substitute the F with the ma, so ma equal to 4T minus F. So we arrange the equation, so we got 4T equal to ma plus F. Okay, so we put the information that we have into the equation. So we got 4T equal to 3,000 kg multiplied by 55 and plus 700 Newton. So after that, we got the we got the answer for T equal to 165,700. So we divide it by 4 because there is a 4T. So the T is equal to 41425. So this is the answer.
My name is Muhammad Al-Birani. My matrix number is AA234. So, for our group, I will discuss for discussion So we point out for the 3 main point, which is strategy, problem faced, and then way to overcome. 5.1, which is strategy. This case study based learning is focused on the general knowledge of the Newton's second law. We need to apply Newton's second law in our daily life as our case study. Our daily life application are car moving on tracks. We use the formula of Newton's second law, which is F equal to ma, which is F equal to force, m equal to mass, a equal to acceleration. So after the calculation, mass, force and acceleration are involved in the application that are started. So from the free body diagram that are from the question, we are able to identify and deduce the following, which is a slight experience a rocket thrust that accelerate is to the right. Each rocket create a identical thrustee. As in other situation where there is only horizontal acceleration, the vertical force cancel. The ground exists an up force and on the system that is equal in magnitude and opposite in direction to its weight, which is W. The system here is the slide, its rocket and rider, so none of the force between these objects are considered. The arrow representing friction, F, is drawn higher than the car. Although there are force acting vertical and horizontally, we assume the vertical force cancels since there is no vertical acceleration. This leaves us with only horizontal force and a simple one-dimension problem. Direction are indicated with plus and minus signs, with right taken as the positive direction. This can be seen from the free body diagram in question. Experiments such as this we perform in order to test the limits of human endurance and the setup designed to protect human subject in jet fighter emergency injection. We further to the 5.2 problem phase. In order to solve this question, there are several problems that we have identified, and the problems are as follows. The system of rocket slide, which is in this case does not accelerate vertically, although force act vertically on the system. This leaves us with only horizontal force to consider. Next, we need to consider the magnitude of these quantities in the calculation because all force and acceleration are along a line. By apply the concept of Newton's second law, we are able to look for a way to find the thrustee of the engine because all force and acceleration are along a line. To draw the free body diagram accurately, we correct magnitude and direction. And lastly, the possibility of movement such as random error when usually calculated to calculate and solve the value. For 5.3, way to overcome the problem. To overcome the problem, there are several ways to solve them. To overcome the first problem, which is the force acting, particularly on system and leaving the horizontal force to consider. Those to overcome this, we decide to assign the direction to the right as the positive direction. Next, after considering the magnitude of these quantities in the calculation, because all force and acceleration are along a line, thus we can solve it by deducing that applying the concept of Newton's second law, we are able to look for a way to find the thrustee of the engine as all of the force and acceleration are along a line. Number 3, to prevent incorrect free body diagrams result, we need to correctly define the magnitude and direction by making assumption and identifying the force, weight and rocket propulsion. Number 4, repeat calculation multiple times in order to correctly determine the correct answer. Plus, by doing this, we are able to reduce the chance of random errors when calculating using the calculator. With this, our answer are valid and free from error. Free from error. From me, we give to the next presenter.
Okay, for the conclusion, force, mass, and acceleration are common terms, although they are frequently misused. Newton's second law is at the root of all of the above. So, according to the second law, an object acceleration is determined by two variables, the net force acting on the object and the mass of the item. This law, according to NASA, states the change in momentum per change in time it is equal to force. Force equal to mass times acceleration for a fixed mass. So F equal to ma is the mathematical expression for this. F stands for the force, m for the mass, and a for the acceleration. This is straightforward mathematical problem. When the force is double, the acceleration is double. When the mass is double, the acceleration is cut in half. Okay, thus by doing this project, we are able to achieve the main objectives of this project, which is to apply the understanding of force, mass, and acceleration for the Newton's second law of motion. On a real-life application, this is for the rocket slide tester. Okay, not only that, we have also able to achieve other specific objectives as followed. First, to identify the type of force acts on an object and to use that information to construct a free body diagram. Okay, next, to state Newton's second law of motion, to express in equation form, and to use it to solve for acceleration, mass, or net force if knowledge of two of these three variables are known. Okay, and last but not least, to use Newton's second law equation as a guide to thinking about the relationship between force, mass, and acceleration. Okay, that's all from us. Thank you very much.